to say that if I have to visit only one event in person, if I have the option to choose, I would pick up FOSDEM.
Really?
There are so many great events, but FOSDEM is totally awesome.
Really? Like, why is it so good? What is it about FOSDEM that makes it like the best? I've not been.
Well, the first thing that impresses me is the culture, because there are people from all around. I would even say all around the world nowadays, and it's very relaxed. There are developer rooms, so many developer rooms. So pretty much you can always find an interesting talk. Most of the time the problem is how to visit 2 talks at the same time or 3 talks at the same time, or to find a place in the room to hear the talk. The really cool thing is that there you can find senior, very, very experienced developers with 20, 30 years of experience, and students at the same time, chatting together, hanging out together. So it's a great place to meet people, to exchange ideas, and to learn new things. And of course, there's the Belgian beer, and it's a free event.
Oh, and it's free. Oh, that's nice. I didn't realize that.
It's absolutely free.
That's cool. Where is it, or does it move around?
It's always, as far as I know, it's always in Brussels. I've been there like 8 or 9 times in a row until this year when it was an online event.
Drop Diet Coke on my keyboard.
Oh. Is it waterproof?
I mean, well, if it starts, if I start like doing some weird commands, then it's fine. It's only a little bit. All right, so I have, in the internet outage, I have prepared, I used my time wisely while I was power cycling my router, and I finally, I got all these screws onto this bad boy. Just make sure he's nice and secure there. And then the next step is to put the OLED on, right? Where does that live? It says, let's take a look here. So
yes, exactly.
Let me just move this here. So basically we said, so we've done step 1, which is to take off the protective films. We've done step 2, which is to attach this acrylic base to the PCB with a couple of nuts as well. That's a nice standoff there. And then the next thing is the mini OLED display. Let's go back here. So it says, carefully attach the display to the front acrylic case as shown in the video. Let's have a little look at this video here. Oh no, I don't have, or you could just tell me. How about that?
Show you.
Ooh, you can show
because
me.
I have one assembled here. So this is the display, and first you have to identify the big acrylic part, which is for the front.
Yeah.
The front and the back have the same dimensions. Of course, they have different mounting holes. There are 4 mounting holes here.
That, yeah.
And you indicate you should have a package of M2 screws. They're really small.
Yeah, I got those.
With washers and nuts. So you have to put the screw, a washer, then the acrylic enclosure, and after that to fasten the OLED display. However, you have to be really careful and not fasten it too tight because it might break these displays.
So
really
it's on
fragile.
the underneath, right? Okay. So
yes.
we do a screw, a washer, then acrylic.
Right? So it's a screw, a washer, acrylic, then the display, and finally the nut.
Okay. So there's only one washer in this situation, right? And then we've got these little baby nuts here. Oh my goodness, they're very small and fiddly, which is good.
Yeah, they're empty.
Yeah. I've chosen the one like right next to the jumper cables as well to put on. Maybe I'll choose a slightly easier one so I've got a bit more room. Yeah, so we've got the nut, we've got this, blah, 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 blah. Then let's pop him through the mounting hole on the PCB. Oh, I can see here that it would crack if you, because
I have to admit that that this is not a very good engineering out of me, but in my defense, doing mechanics is something that I'm not good at.
It's fine. We just have to not break it. Just not have to not be. There we are. I think that's okay. All right, let's do the same for the other ones then. All right, so I got that first one in, which I have cleverly placed off screen there, as if I were just doing it for myself. All right, so here's the second one that's just gone in, and I'm just using I always use just like a little, I've got this little tiny set of screwdrivers that I just keep on my desk. They're coming handy all the time. So I'm just using a tiny little magnetic screwdriver to hold it in place while I flip it over and smash that nut on. Whee! And I hold the hold the nut in place and then twist the screwdriver just because I find that easier.
Yes, absolutely. This is a very good approach. Although you can do it with your bare hands, if you have a screwdriver nearby, it makes things a lot easier.
Yeah. Especially when you've got sweaty little fingers from being under some lights. Which I do. All right. So you say these are M2s?
Yes, exactly.
They seem very small. I mean, I've got in my little component box, I've got like an epic amount of M3s. So I don't which tend to be like an all-purpose nut for me. But now, I'm just thinking, actually, 2.5 might be superior. I don't know. Maybe I have to, step up my screws and nuts game. All right, last screw for the OLED, and then I'll tighten it a little bit, but not enough to destroy this hard work. All right.
Just to explain something I think interesting about these OLED displays. So they're quite popular, and you can find similar displays on many places. They have different color combinations. The one that you are touching is as you can see it here. When you turn it on, it's going to be yellow,
nice.
and below it's going to be blue. However, a lot of people don't like this color combination. So since it's an open source project, anyone has the freedom to change the OLED display, and you can find similar or compatible OLED displays all around. And some of the other OLED displays might have bigger screws. So if someone decides that wants to change the display, have different colors, and use, for example, an Adafruit or something like this display, most of those displays have the same dimensions, but some of them have different holes. That's why we have the washers. And this means that even if you have a display with a bigger mounting holes, it should be possible to fit it in the acrylic enclosure.
Nice.
Of course, it depends on the model, but in general, this is something that I had in mind when I was designing this. Super simple.
Very cool.
Super simple acrylic enclosure.
So we've got our base all set up, ready. We've got our OLED. I've had a little sneak peek at the next step for us, and I'm very excited because I get to use the giant nuts, and we get to put this fan filter in now. All right, so I'm going to attach the 4 screws to the front acrylic closure with 4 of the nuts. Oh, similar situation like the last time, right? So we're making a little sandwich. Okay, we can do that. All right, so...
Yes, it's pretty much the same approach. We are using these 4 nuts in order to secure enough place for the filter.
So I've just put the nut through. The screw through, and then I'm putting a nut on the underneath, right, to space. Yeah,
yes.
Okay, good.
This way, it fastens the screw to the front acrylic enclosure and secures enough place for the fan, so the fan can go here.
It's very, very exciting viewing here. Me screwing this nut all the way down. Yeah, here we go. Wait.
So these are M4. That's why they're so big, and I think they're
pretty chunky. I've got to say.
Yes.
All right, finally we got to the end.
And they're pretty heavy.
They are. They're actually really satisfying to work with. I'm having a nice time. All right. And then we put the fan on next, right?
Then it's the filter first.
Oh, the filter first.
First you have to put the filter.
Oh, you're saying this is where you can put different filters on, right?
Yes, if you want, you can change. And actually, you have to change these filters from time to time. It's the filters are replaceable. It's just a kind of a disposable filter that it's a good idea to change it from time to time. I'm sorry that I don't bring my other fume extractor, which is on my soldering desk, because there I have to change the filter. I haven't done it yet, and pretty much the filter went from like black filter on this, and the one you have to something that's more like a white filter. So this is a clear sign that it has to be replaced. Of course, there's some smart features that can be developed and have an automatic some kind of alert and say, hey, change the filter, because the fume extractor is compatible out of the box if connected to a Wi-Fi and an MQTT broker with Home Assistant. So it can be connected to a Home Assistant instance. And once you have it in the Home Assistant, actually, this is a little bit embarrassing, but right now in the place where I still don't have a Home Assistant, but it's on the roadmap, and I'm a huge fan.
I don't have one. I mean, to be perfectly honest with you, I find them quite creepy. Like having, you know, like I want an open source privacy forward system, you know?
Just to make sure, I'm speaking about the Home Assistant open source project for managing the whole system, not only the speaker.
Okay.
Although I have to admit that I'm a huge fan of the Nest speakers, just because they're cool, and I have one here that I should turn off to make sure that they're not listening to the live stream.
Where's the airflow? All right, so I've got these things. So basically, I've put my screws on. I've secured them with a bolt in each of these 4 things. So I've got to put this on now. Now I've noticed that there is on the fan. So the filter goes first, right? So I'm putting the filter in, and then and then like so. There's 2 of them. Do I put both in?
You put the filter, and then you put the other acrylic part, which is the square acrylic part.
Should I put both filters?
No, it's just one of the filters.
Okay, so I got a replacement then.
Yeah, it's just to make sure that you have a replacement when the time comes.
And then this, I'm assuming, goes there, like that.
Just look. I'm looking at the stream, but it's a little bit.
Oh yeah, of course we're out of date. So add the acrylic enclosure that separates the fan from the filter, which is the one that's divided into quadrants. And then on the side of the fan, you will notice a label, which I do, that indicates the direction of airflow. So we've got airflow going this way. So essentially, we want it to go, so it flows through the filter, right? Well, obviously, that's the whole point of this thing. Let's turn this upside down there.
Yeah, exactly. Yeah, so it should take the fumes from the soldering iron, go through the filter.
Yeah, not the other way around. You're not like pushing the fumes towards our face, right? That might be not ideal.
That could be an interesting prank.
Yeah. All right. So we've put that was nice and easy. That was quite satisfying to do. So I put the fan on so that its airflow goes from the front of the device to the back of the device. Look at that. Very nice. All right. And then the next thing is screw the standoffs. All right, we can do that. Screw off. I love standoffs. I love a good standoff. I really like, because you can get some really attractive ones as well. I've got some really nice looking brass standoffs, which I really like. So I'm a big fan of a nice standoff.
Well,
these are quite
finding
chunky
these
ones.
M4 20 millimeters standoffs was a huge challenge.
Really?
And finally, yes, I found a supplier here who imported them for me from Germany, because obviously people don't use this type of a standoff very often, at least here in Plovdiv. So it was a challenge to find it, and this is the bottleneck of the project. This is the part that is most difficult to obtain, because all the other parts are like open source certified open source hardware and software. And most of the other components are off-the-shelf components. However, this standoff is more tricky to find.
Well, I appreciate the sourcing effort that went in. I am enjoying these giant standoffs, that's for sure. I'm just screwing them in nice and tight here. Whee! Standoffs are fun. Look at that. Oh, we're zooming along now. It's starting to look like an actual thing. That's exciting. All right, so we've put we've got a filter in place. We've got our little acrylic standoff. We've got the fan, which is flowing the correct way, i.e. away. And we've got the standoffs. So that's actually starting to look almost like it might become a thing soon. So we've done that. Okay, so the next step, which is optional, is the light sensor module. Do I have this? I've got the gas and...
I have to disappoint you, but the light sensor is in the developer kit, and I believe you have an advanced kit, so you don't get the light sensor. But you can always get a light sensor and put it after that.
All right, that's fine. So the next step then is to connect the peripherals to the old board, I guess.
Yes. Exactly.
Yeah. All right.
And this is more tricky than it sounds because there is a lot of wiring going on.
Oh, I like
at that moment.
All right. So I've plugged in my. I mean, there's only one place that the fan can go really. So then which is onto this little. Oh wait, let me just put it so you can actually see the damn thing. So we've got a little JST connector. I've got that right. Yeah. I think.
Yes, exactly.
Yeah, that plugs in the fan to the board. Then I've got, what else have I got? I've got a gas sensor. Does that just go straight in?
Yes, it goes straight in, and the direction should be that the sensor itself, the gray part, like should go through the acrylic enclosure, as you can see it here.
Oh, I see. Yes, I see. Oh, I see. So it's this one. I get it.
Yeah.
So this is for the gas sensor. We've got we've got VCC, ground, DO, and 8D. So that just like plugs. Oh, yeah. That's very satisfying. I like it. Hang on, wait.
So just to explain about this sensor,
that's nice.
In general, this very simple sensor, it's just for detecting the air quality. It's not for measuring the air quality.
Oh, I see.
However, based on the analog values, there is a voltage divider on the board, and depending on the values read from the voltage divider and the built-in analog to digital converter on the ESP8266. The algorithm in the Arduino sketch is giving some basic approximation if the air quality is good, or if it's moderate, or if it's poor, and you need to take some measures such as opening a window or having some extra fans to extract the fumes.
All right, so I have put it in. It fits in nice and neatly. It pops through there. I just double checked it. So it puts his little face through the acrylic, so it's out on the outside, which is kind of cool. I like that.
Yeah, it should look like this.
No, it works. Yeah, that's fine. Okay, so now we've got. Let's wire up this display. And I've seen on this baseboard, there is a label for display already, and I've got, your typical ground 3.3V, SEL, and SDA there. So it's an I2C. Then I'm guessing.
Yes,
device.
Exactly.
All right. So what have we got here? So we've got this green one's ground. All right.
The colors may differ because.
Yeah, that's true. Sorry, I was more for my own. I had just noticed that the green one is ground, but it's not like it's just a jumper cable. They don't mean anything.
So, on the top of the display, there's very small labels indicating ground, VCC, and you have to look at these and to make sure that they match on the
So we've got ground going to ground. We've got VCC going to 3.3V. Then we've got our SCL, which is the clock, that's going next. So they actually match up. Sorry, I didn't put it in there. Where they it matches up quite nicely. So basically, yeah, we've got ground, VCC, SCL, and SDA. You can see that on the silk screen here. And then if you flip it over, you'll see this goes in to this bit of this baseboard, and it's got ground, which you connect to ground, 3.3 V, which you connect to VCC, and then SCL and SDA connect to their respective ones as well. Right, so we've got the display wired up. We have got the gas sensor wired up, or what's this last one? I know you told me earlier in the stream, but I've forgotten. What's this last sensor that I've got?
Well, yes, the last sensor is H221D, which is for temperature and humidity.
Okay.
You can see that there are 3 additional slots on the board for
yes,
I2C sensors.
So there are.
Pick the slot that you prefer and just plug the sensor the same way as the display. Just make sure that the wires match the direction of the sensor module.
So what I'm doing here is I have got a temperature, humidity, and it's barometric pressure as well, right? That's what that little hole is for. Or is that humidity?
It's just humidity. However, the default sketch also supports a separate sensor for temperature and barometric pressure, BMP 180 or compatible.
Yeah. Okay. Yeah, it's a BMP 180 I've seen before. It just reminded me a little bit of that sensor. Anyway, so we've got 4. We've got these. This is my little additional sensor that I've got in here. So I've got on this board, I've got SDA, I've got SCL, I've got ground, and I've got V in. So SDA goes to SDA, SCL goes to SCL. You've guessed it. Then we've got one going into ground. And the final one, I'm doing V into 3.3 V to give this nice bit of power there so we can actually use this thing. So I've seen I've got quite a few slots free here as well, so I could probably put in a couple of other I2C devices as well if I wanted to.
Yes, absolutely. The developer kit contains 3 sensors. However, it's also possible if you want to modify the source code or write down your own sketch, Arduino sketch, and use different sensors. This is again part of the flexibility of this project. So these I2C sensors are pretty much plug and play. Once you have, of course, the firmware that supports them.
All right, so now it says finally, we got to the end bit. It says finally assemble all acrylic enclosures by fastening 4 M4 nuts on the back of the fume extractor. Okay. Am I supposed to put the sensor like out of here? What are these bits for? What are these slots for? Should I just leave the sensor inside, or?
So you can put it like this, if you like, of course. I have put it on the back here and bend them over there, so they're over here. These are the sensors.
Yes. That's a good idea.
The developer kit includes one extra sensor for light, which I prefer to put here in front. However, the other sensors for temperature and humidity, they're not necessarily needed to be in front, so it's okay to put them on the back side of the fume extractor.
Okay, so what I've got left here is I've got my baseboard with everything plugged in. I've got the front bit with my fan and my display. I've now got 4 nuts left. So apparently what I do is I'm going to pop my, why do I say pop? It's a Welsh thing. I'm going to pop my baseboard into the front bit. Hold that steady for a minute. I think to angle it. Okay, right, and then I guess this goes onto here. It's like a jigsaw puzzle. All right, here we go. Here we have all of this stuff. That looks about right. Let's finally put in these nuts. Hold it all in place, and hopefully it'll be assembled. That didn't take that long. I thought this was complicated.
Actually, you're doing a great job. You're better at assembling this from your first time than me after assembling several of those.
I told you I like doing IKEA.
Yeah.
I've assembled a few electronics kits in my time, Leon. There we go, look at that. We're done.
Very well.
Yeah, all right. I think, look at that, isn't that exciting? Woo. Let's see if that goes round and round. Yay.
That was quite fast, you know. I say that it takes more time than it took you to do it.
I'm very talented, Leon.
Yeah. Oh, that is. I'm happy to see that it went so well.
Yeah, I mean, it's, you know, that was fun. All right, let me. So I've put that there. I've put my little sensor on top as well. So let's just tighten some of these nuts, and then let's turn it on and see if we can make some of the example
just
code
to
work.
tell you a couple of things before we turn it on. So
Yeah.
the first thing is that if you look on the side, you notice one button here, which is for the fan switch. You can manually turn on and on the fan once it's working, and the second one
You
is
mean
the
the
jumper
little push
wire.
button, the momentary switch by the relay thing? Is that relay?
And sorry, I said a jumper wire, but actually just the jumper. So there is a Wi-Fi jumper, which by default should be set to off, which is just to get started in a simple way. So if you want to connect it to and to utility broker and home assistant, IO broker, or another home automation, open source home automation platform, you can set this Wi-Fi jumper to on and then plug on the.
How do you set that to on? Does it switch?
For the moment, for this demonstration, I think it will be easier to keep it as off.
Oh yeah, totally. I totally will.
Yeah.
But this is just a configuration with the little. So it's like these little header pins, right? And then we've got this little. Is that just bridging the two pins? Is this
yes, exactly.
the little hat
and
thing?
I have to say that the firmware is reading it only once when it boots. So if you change this configuration, you have to reboot the board by plugging on and off the cable, the USB
That makes
cable.
sense. That makes sense.
And this jumper for the older people like me should remind the CD-ROMs and how we were selecting primary or cable select on the back. So.
Oh, so cute. Oh. All right, so we have got a fully constructed, wired up little creature. Do you know what? I'm actually going to slap a sticker on it because, you know, let's give a little, let's do a little keycad sticker straight away. You know, where am I going to put that? I'm going to put that on the bottom so I remember where it's from. We actually have quite a lot. So do you do all of your circuit design in KiCad?
Yes, and for the acrylic enclosures, this is something that I forgot to mention. I used OpenSCAD.
Nice.
It's unconventional for 3D designing, but I said my primary job is software engineer, so I like coding, and coding very simple. As you can see, it's a very simple design. It's something that I really enjoy. So,
well,
and of course, everything is available.
Wait, can I put it here? Here we are. Look, there it is in the main camera. Let me just put it on there. Let's change to this one so you can actually have a look at it. Ooh, look at that. That looks pretty good. It's actually pretty small. It's smaller than my face, so it's going to sit quite nicely on my workbench there. That's pretty cool. Doo-doo. It's actually quite nice. It's pretty compact. It feels more solid than I was expecting, considering it's made of like 3 bits of acrylic and some nuts, right?
I'm glad you like it, and you did it in no time. I was expecting it will take you more time to assemble it. I'm really impressed. Now, fingers crossed it works.
Yeah, I know, right? So what's the next step then? So it's all made.
Just to let you know about another thing about this sensor. According to the datasheet of this MQ135 sensor, there is this so-called burn-in procedure. Despite its fancy name, it's actually a simple thing to do. After turning on the board and the sensor, the board will provide 5 volts to the sensor. It needs at least 24 hours to calibrate itself. It's initial. initial calibration, or if you don't use it for several months, you have to go through this. During that time, it will say that the air quality is poor or something like this. You just need to leave it turned on. I mean the sensor turned on.
Okay, so it's just a calibration process that takes 24 hours.
Yeah. Yes.
Nice. 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 All right. So, shall we try and turn it on? I think we can try and turn it on. This is very exciting. Here we go. So desk down cam again. Here we are. Look at this. I think it looks really cool, actually. I think it looks really cool. It's quite friendly somehow. All right. So let's play the game of, is this a real USB cable or is this a power-only USB cable? I'm pretty sure this is the real one. So is it an Arduino?
It doesn't matter because the fume extractor uses USB only for power. So if you want to reprogram it, you'll need one of these cables.
Oh, yes, of course. Yeah.
USB to your cables.
Yes, you already told me that, but I had already forgotten.
I'm cheaping out because this way we're not putting USB to UART chip on the board, but instead we're using external cable, which in most of the cases is even more practical.
Look at that. That's exciting. Whoop, no, wrong one. Look at that. There's some lights. Oh, it's working. It's working.
Oh, fantastic.
Yeah, look, here we are.
Well
so
done.
we've got, the air is 25 degrees Celsius. Oh, it's nice to see a Celsius. I'm currently living in the land of Fahrenheit, and it's terrible. So we've got air quality is poor. But yeah, that's to be expected because it's calibrating. And the fan is indeed on. I feel the fan. That's pretty cool. That worked pretty seamlessly. I mean, apart from that internet apart from the internet failure, this whole thing went reasonably well. So let me just see. I'm going to just press that. There's a little momentary switch. It looks like just a little button here. And now it's off. Now it's off. Let's turn it on again. So a little teeny weeny switch down here. Look at that. Boom. That's pretty cool, huh? So basically, I need to leave that on for 24 hours now for the air quality sensor to calibrate. Is that correct?
Yes, exactly.
Amazing. So should we take a little look at some example code? Like, I'm not going to try and program it now, but we can take a look at your GitHub. We can take a look at how to program it as well, because I think not everybody will have used one, will have programmed something this way before with the little connector, which I have flung somewhere on the floor. Hang on. Oh, here it is. I find it. Here's my little connector.
Yeah, absolutely. So this is actually one of the best friends of embedded developers.
Yeah.
Because it's a super simple thing. You basically plug it into your computer, and over UART, which is actually quite a slow way to transfer data, but it's quite efficient. And the firmware it's not huge. So with these just 3 cables, which one of the cables is of course ground, the other are for receiving and transmitting data. You're transferring the firmware from your computer to the fume extractor. And there are several ways how to do this. The first way is the developer's way. You can download the Arduino sketch, configure Arduino IDE or platform IO to be used with generic ESP module, ESP8266 module, to be more exact, and to compile the source code, to flash it on the device. And actually, this is a great approach for developers, because this way you can inspect the code and you can make sure that, hey, this code is what you expect it to do. And I'm super excited that a lot of people are doing it this way. And sometimes they find bugs and submit GitHub pull requests with improvements, actually also providing some interesting new features. The other approach is that I also have in the GitHub page, there are pre-built binaries, which people can just download. This saves time because you don't need to set up our.
Mm-hmm. Amazing. So I'm taking a little look at your GitHub right now. So we were doing the build from this crowd supply assembly, on the assembly guide that's on crowd supply. Then this is the GitHub here. So if we have a little look at your, we've got all sorts of, you're very good at your documentation, Leon. You do really put things. I mean, this is really nice. This is nicely organized. Here we are. Look at these nice dependencies and the manual and all that kind of stuff. It's very good. Let's not look too closely at it then. It's working. It's working. We won't tell anybody. So, John, so is this the default? Let me put my glasses on here. If I'm looking at some code. So tell me what I'm looking at here. What is this? We've got a few examples, right? Here's the fume extractor. Here's the fan. Whoa. Mm-hmm. Yep. Mm-hmm. Mm-hmm.
I think we lost Leon's audio on YouTube.
Mm-hmm. This one. This is the, yeah.
I don't think YouTube hears Leon.
Oh, hello. Oh my goodness.
I can hear you well.
You can hear. We can hear you fine here. But when I switch over to this screen, this is from when we crashed before. Hang on, 1 second. Let me just pop you back in here. Give me 2 ticks. Leon again. There we go. There we go. Let's put you here. How about that? That's you're frozen. You were frozen, but that's because we didn't replace you. I know he's back. I've just put him back. How's that? Let's slide you down. Thank you for the shout out to tell us that. There we are. Look, he's back. Let me just change this. Oh, the joys of streaming. All right, so here we go to the left. You might have to, here we are, let's pop this back over here. Do you want to explain your GitHub repo again, seeing as I completely failed to, there we are, let's have a look here. So go back to this main page. So this is your, do you want to talk them through this while I make your face less weirdly shaped? Yeah, so we've got this, can you see the GitHub, GitHub there? There we are, I reckon that will probably do. There we go, look at you. Oh, look at, we've got you back, Leon. So, ta-da! All right, there we are, so we're sorted. Let's try the GitHub tour again, this time with Leon not being a frozen face. This time, I'm not just talking to myself with an image of Leon frozen in time. All right. So yeah, we've got so under your GitHub, we've got a whole bunch of different docs and examples. The fume extractor software is in its own folder here with the link to the user's manual. That's the link to this, which is what we were what I was using to build it earlier. We've got all these lovely dependencies, and then we've also got, so this is, correct me if I'm wrong, Leon, this is what is currently running on my fume extractor? Is this what is on?
Exactly.
Okay, so can you talk me through a little bit what this is doing and what our options are if we were to, God, there's a hell of a lot here.
Yes, so the majority of the Arduino sketch is actually for the MQTT connection. MQTT is machine-to-machine protocol. It's nowadays it's widely adopted in home automation. So basically, you can have an MQTT broker running at home. By default, it connects to a public broker, but this is just for demonstration. It's not a good idea to leave it this way because someone can hack you.
So for those of us who don't, for those viewers that don't know, what is Home Assistant?
Home Assistant is a very popular free and open source software for managing Internet of Things at home. It works with thousands of devices. It's written in Python, perfect to run on a Raspberry Pi, as well as a bunch of other single board computers. Even Home Assistant recently launched their own thing, a small hub, very bright and shiny, really well looking. So this is a home automation platform which solves the big problem how to how different devices from different brands can work together. Opportunity for devices like this, do-it-yourself kits, also to connect to Home Assistant and work. My approach is using the MQTT protocol. This is the transportation protocol. It's over the Internet protocol, of course. It opens sockets, so it's in near real time. If I'm a salesperson, I would say real time, but as an engineer, I have to say it's a near real time. So
yeah, there's no such thing as real time. I think it's a myth, right? the more technical, like when I have a conversation, like the more technical the person, the more they're like, no, it doesn't exist. Yeah. Like, yeah.
So the whole thing that you see here in this sketch, so how it basically works, if you turn on the Wi-Fi jumper, then
which is what we looked at earlier, yeah, that little jumper switch, yeah. If we turn that on,
what happens is that the firmware will create an access point. And after that, from your smartphone, you have to connect to this, a smartphone, tablet or computer, whatever actually you prefer, to connect to this access point, which is running on the fume extractor.
That's cool.
Then there is a captive portal, which captive portal will ask you to select your Wi-Fi network and to add credentials as well as to fill in your MQTT broker. Of course, you can use a public MQTT broker for the demo purposes as well. And once you're ready, you save this data, the fume extractor will turn off the access point and will automatically try to connect to your Wi-Fi, and after that to your MQTT broker. If something fails, for example, if the Wi-Fi password didn't match or something like this, you have to go through this procedure again. And once it's connected, it reports data from all these sensors that we have on the back, on the front, over MQTT. And it's possible to turn on and off the switch remotely. So it's in theory, it's possible to turn it from your smartphone or whatever other gadget you have.
Do you have an example of what that looks like on your phone? Do you have the app on your phone? And also, how do you emotionally feel right now? Like that I'm scrolling through your code, like live on the stream. Like I'd be like, please scroll faster, scroll faster.
Yeah. My primary job is a software developer.
Yeah.
I work for a consultancy company specialized in embedded Linux, and I do these things on my side, and I have to say that my source code is embarrassing. if I have to look for a new job as a software engineer, probably I won't show this project. But yeah, basically
it's so nerve-wracking having somebody else look at your code, especially if you've not spent like loads and loads of time. You're like, oh my god, must look like such an idiot.
It's,
I'm glad to know that you feel the same way too.
Yeah, it's basically this code needs a little bit of a refactoring. It's one code that I bring along. The whole procedure for connection and so on is used across several of my projects, and all of them need improvement of the code. And I have to say that the open source community is helping a lot, because there's so many people contributing and improving these Arduino sketches, which is wonderful. And I have to say a huge thanks to all these people for using the device and improving it. It's not only bug fixes, but a lot of new features come in. So it's amazing.
That's really cool. So we've also got the this really awesome folder here of your examples. Do you want to tell us, because remember, we cut out earlier. So you were just a static box while you were explaining all this different folder of awesome folders. Do you want to tell us a little bit about this?
Yes, absolutely. So the examples are simple examples for all these open source hardware boards that I have. And we have a directory for the fume extractor, which is an Arduino sketch that just turns on and off the fan without any complications of Wi-Fi, connectivity, and Qt, and so on. So it's a very basic and super simple example.
Oh, look at that!
Actually, it's
50 lines.
Because I'm using this example to try out all the fans before putting them in the kits to make sure that hey, this fan really works. So it's a useful example, at least for me.
Nice.
Not sure if anyone else is that interested in it, but for quality assurance, it does the job.
But you've got a lot of other things here as well, don't you?
Yes. Some of these things are not officially available. They're just GitHub repositories. But yeah, you can find for all those boards that I have created or I have in mind to create some simple examples there.
That's fun. Have you got your, is this your, no, where's your, if you got your macro pads on, any code for that here, or is that in, we don't have to talk about that, but I mean, like, that is coming up. Do you know what, we can have, do you know what, I can put, so Gabe, who works at Crowd Supply, and has done all the visuals for this stream, he's put together a tiny little video of all of the projects that you've released on Crowd Supply. So if you're up for it, it's only like 2 minutes long. We can watch it, and you can give like a commentary on it. I don't have your audio in on that video yet, but I can make that work. Would you be up for that?
Absolutely.
All right,
that sounds fantastic.
Let's switch over to the video. There will be no sound for about 10 seconds while I dial us in, but you can enjoy the video anyway. All right, here we go. Let's switch over to video.
Awesome. Okay. I'm watching the YouTube stream and it's a little bit behind. Okay, so it started.
So you should be able to hear me now as well. That's very exciting. All right.
I think
so there's two of us.
If you notice, one of the boards is the gas detector. It's very similar to the fume extractor, because first I created the gas detector, and after that I said, hey, I can use the fume extractor with this thing. So these boards are quite similar. I would divide these boards in 3 categories. One is my favorite Raspberry Pi Atom boards called heads, hardware attached on top. And the others are Wi-Fi boards with ESP. And the third one is something relatively new. These are the keyboards, like this little bit.
The macro pads. Yeah, I'm excited about that one. That's let me turn my mic down a little bit because it's going off the reds. Yeah, I'm excited about the macro pads. So the macro pads, there's one of them in this video which has got 8 keys, right? Oh look, one that's just come up. Here's the solder, the fume extractor, little video of that. That's what I've just made. But the macro pad, you've got the one which has got 8 keys on it, which I would like to get my mitts on to make into a stream deck in a future live stream. But you've also got something else coming up as well. You've got a macro pad 2, is that right?
Absolutely, yeah. It's a tiny macro pad, despite the fancy name. But yeah, you can use these keys for macros. And actually, I'm using it today for controlling the mic and the camera during the stream. I can show you how I can turn off my camera for a second.
Yeah, hang on. Let me just put you. I'm going to put you back to. There we are. There we are. Ta-da.
Right.
So do that again, so I can see you. We can all see you now. Oh, you turned yourself off and on again.
Yeah, so it's reprogrammable thanks to the awesome open source QMK firmware. Initially, as a software engineer, I said, I'll write my own firmware and it's going to be super cool. And then I realized that, hey, QMK is super cool. It already exists. It supports thousands of keyboards. Why don't I just add my stuff there? And that's what I did, because this was the better thing. Actually, a friend recommended me QMK, and I'm really grateful for this recommendation. So this is a very simple board. It's with microchip 80Tiny85. I love this microcontroller. You can find it in so many soldering kits.
Yeah.
And considering the main topic of this live stream, I'm sure a lot of people are familiar with it, because anyone who's interested in soldering has, at least once in his life, has done a soldering kit with 80Tiny85. And I had one kit from Olimex, a Penguin, and I decided, hey, maybe I can add a couple of buttons to it. And after that, I came up with this little board. Which
it's very funny.
It's a keyboard.
I like it. What did you call it on Twitter? It's a 2% keyboard. Does that mean it's got 2% of a normal keyboard's keys?
Yeah, although I'm making kind of mechanical keyboards, I'm still new to this huge community. It's an amazing community. The mechanical keyboard community is totally amazing, and people there really like to say like 60% keyboard or 100% keyboard, something like this. And this
I've never fully known what it means. I mean, I've always just assumed that it means it's 60% of a full keyboard, but I've never actually, tested my assumptions by looking it up on the internet.
I have to say, this is not the first keyboard with 2 buttons, but I believe this is one of the very first open source hardware keyboards. And I hope people would like it. It will be, actually, it also supports combo keys. Let me show you. You can adjust the backlighting here.
Nice.
It didn't work out as expected. Maybe I didn't press it too fast.
You keep muting yourself. Wait, we did it? You've still muted. You're muted, mate. Wait.
I have to double check this. I have to double check the firmware. This was unexpected. But basically, yeah, it supports, I have to fix the key map for Skype. But basically, it supports when you press the 2 keys simultaneously to adjust the brightness of the LED so you can turn it off.
Nice. We love it.
This is the curse of the demo.
Of course. Look, my God. I mean, we made the thing. We looked at the code. Like, we've only dropped out. Our stream only disappeared once. Which it's not ideal, but we'll take it. Yeah, no, it's the curse of a live demo. Actually, we've done pretty well for a live demo, especially since I somewhat stubbornly and probably quite stupidly didn't test the kit before I started making it live. So it's a testament to your hard work and engineering that it worked first time, because it, yeah, so it's pretty cool. It's still working away here. I'm very impressed with it.
I think it was a great decision because this way you showed what people should expect out of the box. It's the genuine experience.
It works really well. It's actually cool. I'm using it to cool my hands down slightly. It's very pleasant. and it looks, and it's going to look really cute on my workbench as well. So I'm really happy about that.
I have to say, and I saw that other people wrote it in the comments, your workbench is totally amazing. And honestly, I'm jealous. I'm jealous. I want something as cool as this.
I love my workbench. It's taken me quite a long time to get it how I like it. I've got some ridiculous lighting going on here. I have got some, like, I love this bench. I spent a long time researching my workbench because I rent here, so like you can't put toolboards on the walls, right? So I had to find a workbench with an integrated pegboard at the back, and I'm really happy with that. This one is from a Chicago hardware store called Maynard's, or whatever that is. I don't know. Anyway, I'm very happy with it. I've got you can't see it, it's out of shot here, but I've also got a little tiny 3D printer trolley that you move round and round. You know, just I'm basically making the workbench that my 17-year-old self would have been proud of. That's my ambition. It's got to be aesthetic and it's got to have all the tools, all my dream tools, you know.
It's super cool.
Thank you.
It's super cool.
Thank you. I do like it. It's quite inspiring to me to have a place like that. Yeah. Well, Leon, this has been absolutely lovely. I've had the nicest time hanging out with you and making your kits and talking about nerdy things. I think it is time for me to let you go and get on with your evening. It's evening with you, right? It's lunchtime for me. And I'm not just ending the stream because I'm hungry.
Yeah, it's almost midnight here.
So you got to go to bed. You got to go to bed, and I've got to go and get my lunch. But it was really cool to hang out. Isn't it amazing? Isn't the internet amazing that we can like just hang out and make something on camera from the other side of the world to each other? And like we're only complaining because the internet drops once. Like, come on, like that's actually not so bad. The internet is
thank you very much for organizing it. It was a lot of fun.
Thank you so much.
I really don't know the exact words how to say thank you enough for this. I had a lot of fun, and it was.
Well, we'll do it again. We'll get together again once I've sorted out. I'll probably like hardwire my internet, or like just go around and like bully my internet provider until they give me a more stable service. It does occasionally cut out, which isn't ideal for streaming, but you know we do the best with what we have at our disposal. Yeah, it was really fun. Let's do this again. We'll do a macro pad one because I have never built a mechanical keyboard. Probably because I'm the loudest typer in the world, and I think like my next door neighbors might come over and kill me. But I would love to. What I want to do is try and get your MacroPad 8 to work as a stream deck thing. Open source hardware stream deck. So that's the dream. That's the dream. And we'll do that. Like we'll book in another session. That'd be really fun. But yes, thank you so much for being. Wait, I can put you back onto this one. Look at this. Way. Thank you so much for being our guest today, Leon. It's been an absolute pleasure to hang out with you and make some cool stuff together. Some cool open source hardware. This worked really well. It's still buzzing away on my desk. I can't wait to hack it and make it do something very exciting. Not that it's not already very exciting. It's removing toxins from my air when I'm soldering. And thank you everybody who joined us, particularly if you stayed beyond the first crash and burn. We made it to the second stream. Thank you so much for joining us, and have an amazing weekend and happy hacking. All right. Bye.